Select the major product of the following reaction. So we see that the starting material that we have contains two ester groups. So this is what we call a diester. And we're treating this with a base that is the same as the leaving group on either one of these esters, followed by an acid workup. So hopefully we can recognize that these are Claisen condensation conditions. So Claisen condensation being the condensation where you react together two esters. It's just the two esters that we have in this case happen to be attached to each other. So this is going to be an intramolecular reaction. And so what we want to do is just decide where we're forming our enolate and where we're attacking the carbonyl. And since this is symmetrical, we can form the enolate at either one of these alpha carbons and then assume that that enolate is going to attack the other carbonyl. And so to figure out what we're doing here, when you're doing this intramolecular reaction, you're going to be forming a ring. So we really just want to count to see what that ring size is going to be. So if we converted, say, some of this carbon atom here into the enolate by treating it with this methoxide, then we can count. This is going to react. Let me show you the reaction mechanism first. This is going to attack the carbonyl at the other end. The electrons come up to give you your tetrahedral intermediate. They come back down and you kick off your leaving group. So we will take the shortcut that we have been taking. So this is a shortcut, not a valid mechanism. And to see what we're doing here, we're forming a new bond between this alpha carbon and that carbonyl. So I just want to count the ring size here. So if this is 1, 2, 3, 4, 5, 6. And so that's not surprising. It's very common to form 5 and 6 membered rings in organic chemistry because those are the more stable ring sizes. So if we want to draw the product, since we know it's a 6 carbon atom ring, we can just go ahead and draw those 6 carbon atoms. And we can number. So 1, 2, 3, 4, 5, and 6. So between 1 and 6 here was the new bond that we formed. And then I just want to make sure that we have everything else still attached here. So carbon 1 was your attacking enolate, so it's going to have as a substituent, kind of outside of the ring, that ester group. So we can draw that ester. And then on carbon 6, we had a carbonyl. So we've got an idea of what we're looking for. We're looking for a 6-membered ring with a ketone and an ester, so it looks like A. And let's go ahead and put the numbers on here just to be sure. So here is the new bond is between the alpha carbon of the ester and the ketone. So that's our new bond. So that means that this was carbon 1, 2, 3, 4, 5, and 6.